myself, Vishal Kamble, Assistant Professor at CKT College, Panvel, and today I am going to represent my research topic entitled Cobalt Doped Zinc Oxide Sensor Grown by Co-Precipitation Technique for NO2 Sensing Application. Now, introduction. We know that zinc oxide is a semiconducting metal oxide having wide band gap 3.37 electron volt and extratonic binding energy 60 mega electron volt. Therefore, zinc oxide is very specific attraction for gas sensing. And when we dope any metal in that, then surface to volume ratio as well as grain size of zinc oxide increases. Therefore, we use zinc oxide metal for preparation of gas sensor, and we know that there are many environmental pollutant. Among that, NO2 is very harmful to human being as well as environment, because it create greenhouse effect as well as global warming. Therefore, we took effort to prepare a sensor would detect the NO2 in environment. Now, for that purpose, we use a simple co-precipitation method for preparation of zinc oxide film, and that precursor, that is the zinc acetate, and for doping, that is the cobalt nitrate hexahydrate we use. And in actual procedure, the precursor solution 0.2 molar was prepared by dissolving required amount of zinc acetate in absolute ethanol and methocresol and stirred at 70 degrees Celsius for 90 minutes, leading to the formation of clear and homogeneous solution. The solution was deposited onto a pre-cleaned glass surface. Similarly, for cobalt doping, use cobalt acetate hexahydrate as a precursor. We add 5 atomic weight percent in solution to zinc acetate solution, and this was dropped on pre-cleaned glass surface and dry over 2 hours with the help of UV lamp. And here the formation of zinc oxide and cobalt of zinc oxide nanostructure. Now, next part is what this result and discussion we divided into two tasks, two part: characterization technique, and second one, that is the gas sensing performance. Now, with respect to characterization technique, we studies the nanostructure with the help of XRD, APSEM, and UV visible analysis. Now, first one, that is the XRD analysis. Now, check this XRD analysis of my nanostructure, and I match this nanostructure with JCPDS card number 0.10790205, and we get the amazing result intensity along 101 axis. That is the very high intensity. Therefore, here formation of clear-cut indication of formation of nanorods with hexagonal vertex structure, that is the geometry of our zinc oxide and cobalt of zinc oxide nanorod. Now see, that is the FESEM result at 200 nanometers and 100 nanometers, and here clear-cut indication at 100 nanometer. We see that there formation of porous-like morphology as well as rod structure, and a range of morphology of that is the 50 nanometers average length for structure, and length of nanorod, that is approximately 350 nanometer range. We see there, and we confirm with XRD again. Now, next one, that is the FTIR analysis. For FTIR analysis, we use to detect the functional group as well as chemical bonding. For that purpose, we carry out the FTIR analysis, and we carry out FTIR analysis for zinc oxide, pure zinc oxide, as well as cobalt doped zinc oxide. Then, due to small amount of doping, we see the same result of zinc oxide as well as cobalt doped zinc oxide. But at 496 transmit wavelength, we see the formation of zinc oxide. That is the indication of formation of zinc oxide nanostructure. Now, next performance, that is the next task is what the gas performance test. Now, firstly, we check the temperature effect on our nanostructure, and for that purpose, we take the temperature. We took the temperature in range 120 degrees Celsius to 280 degrees Celsius, and we get the result maximum gas response at 200 degrees Celsius. That is the amazing result at 200 degrees Celsius and 100 ppm NO2 gas concentration, therefore that is the optimum temperature as well as optimum concentration for further analysis. Now see the second graph. In second graph we check pure zinc oxide nanostructure and cobalt of zinc oxide nanostructure at operating temperature 200 degrees Celsius and NO2 concentration that is the 100 ppm, and we get the result. Then cobalt doping zinc oxide show the maximum gas response as compared to the zinc oxide. Why then? That is this due to increasing surface area as well as increasing grain size, that is very attraction for gas sensing performance. Now here the another diagram for zinc oxide and cobalt of zinc oxide. Then cobalt of, here clear cut indication that cobalt of zinc oxide show the maximum response as compared to the zinc oxide gas response. And conclusion, last one, that is the conclusion. We systematically investigated the structure, NO2 gas sensitivity of cobalt of zinc oxide structure with the help of a simple and inexpensive co-precipitation technique. Now XRD analysis confirm hexagonal volatile structure of nanostructure. APSEM show rod-like nano material were formed. Taking into reflection of all the result of gas sensing test, it is decided that cobalt doped zinc oxide nanostructure detect 100 ppm NO2 gas at 200 degrees Celsius operating temperature and has extreme ability in the field of gas sensor, and therefore zinc oxide, cobalt of zinc oxide is a very important material for gas sensor of NO2. Thank you very much.